Arctic News, Thursday, June 11th, 2026. Double Blue Ocean Event, 2026 to 2027. Update. Arctic sea ice. A blue ocean event could be declared when Arctic sea ice reaches or crosses a threshold of 1 million km 2 in extent. On June 14, 2026, the Arctic sea ice extent was 10.68 million km 2, a record low for the time of year as illustrated by the image below, adapted from NSIDC. The Arctic sea ice extent has been very low in the year to date, despite the dominance of La Niña conditions. The Arctic sea ice extent will continue to fall rapidly as the 2026 El Niño is strengthening. Forecasts indicate that this El Niño will be the strongest on record. As illustrated by the image below, Arctic sea ice extent was 10.63 million km 2 on June 13, 2026. Black, lowest on record for the time of year, and a deviation from 1981 to 2010 of minus 3.12s. 2 blue is the sea ice extent in 2012, record low year, and highlighted in purple is the extent in 2016, when there was a strong El Niño. Another measure is Arctic sea ice volume. The image below, adapted from the Danish Meteorological Institute, shows that the daily Arctic sea ice volume was at a record low for the time of year on June 18, 2026, as it has been for years. The April 2026 Arctic sea ice volume was about 18,500 kiloliter 3, as illustrated by the image on the right, from an earlier post, which is very close to the magenta bar, which stands for strong melting, 18,000 kiloliters 3, after the annual maximum volume was reached. The image below from an earlier post shows Arctic sea ice volume through April 2026, with the strength of the melting between the annual maximum, blue circle, and the annual minimum, red circle, highlighted by colored bars, magenta for strong melting, 18,000 kiloliters 3, and green for little melting, 15,000 kiloliters 3. Last year, only about 15,000 kiloliter 3 of sea ice melted away from the maximum in 2025 to the minimum in September 2025, and this relatively little melting can be attributed in part to La Niña conditions. The April 2026 volume was about 18,500 kiloliters 3, so strong melting, 18,000 kiloliter 3, will take place over the next few months, dashed magenta line, as can be expected with a super El Niño coming up. A blue ocean event will occur, and virtually all Arctic sea ice volume will be gone in September 2026. In the above image, the difference between strong melting magenta and little melting green is 3,000 kiloliter 3. With strong melting taking place from April 2026, this may well cause a blue ocean event to occur, with virtually all Arctic sea disappearing in September 2026. The animation below, made with NASA images, shows the Arctic sea ice just north of the northern tip of Greenland from the 3rd of June through June 10, 2026. This is where some of the thickest Arctic sea ice is located. The animation illustrates that even the thickest sea ice can break up with the pieces getting moved by wind and ocean currents into the Atlantic Ocean, where they will melt away. The combination image below, adapted from the University of Bremen, shows Arctic sea ice thickness on June 4, 2026, left, and on June 18, 2026, right. The 2026 El Niño. The upcoming El Niño threatens to contribute to loss of virtually all Arctic sea ice in September 2026, which would in turn result in albedo loss, transfer of ocean heat to the atmosphere, and additional emissions that could jointly increase the global temperature dramatically, and could subsequently also cause virtually all Antarctic Sea to disappear a few months later. Forecasts indicate that the upcoming El Niño will reach historic heights within a few months' time. The above image, adapted from NOAA, shows a sea surface temperature anomaly versus 1991 to 2020 forecast update for June 16, 2026, for the 903.4 region, which is indicative for El Niño development. Forecasts exceed 4 degrees Celsius for parts of some forecast members and exceed 3.5 degrees Celsius for part of the forecast for the coupled forecast system version 2, CFSV2 ensemble mean black dashed line. The image below shows a sea surface temperature anomaly forecast update for June 16, 2026 for the Nino 3 region, with forecasts exceeding 4 degrees Celsius for parts of some forecast members and approaching 4 degrees Celsius for part of the mean. The combination image below shows sea surface temperature anomalies versus 1981 to 2010 in the Nino 1+2 region, located close to South America, where a rise of 4.4 degrees Celsius from minus 1.6 degrees Celsius in the top image to 2.8 degrees Celsius in the bottom image occurred within 6 months through June 17, 2026. The image below is adapted from Climate Reanalyzer and also features in an earlier post. The image shows sea surface temperature anomalies versus 1951 to 1980 in the 903.4 region over time. This region in the Pacific Ocean is indicative for the strength of El Nino. The image has a potential 2026 El Nino anomaly of 3.5 degrees Celsius added red dashed line on the right. According to NOAA, there is a 97% chance of El Nino in May-July 2026 and 98% chance of El Nino in January-March 2027. The image below from NOAA also shows strength probabilities. NOAA adds that there is a 63% chance that El Nino will be very strong in November 2026 to January 2027. The image below, adapted from NOAA, shows El Nino red, La Nina blue, and neutral episodes gray. Temperature. The image below shows that on June 17, 2026, the sea surface temperature, SST, was the highest on record for this time of year in the 903.4 region, 5 degrees minus 5 to green, 120 to 170 to DW, an area in the Pacific Ocean that is indicative for development of El Nino. The inset shows sea surface temperature anomalies on June 17, 2026, with the 903.4 region highlighted. The June 17, 2026 sea surface temperature in the 903.4 region was 29.37 degrees Celsius, a jump of 3.62 degrees Celsius in a span of about 5 months from the 25.75 degrees Celsius recorded on January 9, 2026. SST were higher only during the Super El Nino in November 2015, as marked on the right of the image. The image below, adapted from nullschool.net, shows sea surface temperature anomalies on June 17, 2026. The temperature of the sea surface was as much as 21 degrees Fahrenheit, or 11.7 degrees Celsius higher Lake Michigan, at the green circle, than 1981 to 2011 on June 17, 2026. On June 14, 2011, the world's 60 degrees minus 60 degree, 0 minus 360 degree sea surface temperature inset also shows anomalies on June 14, 2026 was 20.98 degrees Celsius, the highest temperature on record for this time of year, as illustrated by the image below, which also has marked the years 2020 to 3 and 2024, while the year 2025 is colored orange. Sea surface temperatures, SST, peak twice each year, in March-April, when it's summer in the southern hemisphere, and in August, when it's summer in the northern hemisphere. Despite La Nina conditions in early 2026, which suppressed temperatures, 202.6 SST were close to the record high 202.4 SST when El Nino conditions were present. Meanwhile, 226 SST have reached the highest temperatures on record for this time of year. The combination image below, adapted from nullschool.net, shows sea surface temperatures in the Arctic on June 11, 2026, left, and on June 16, 2026, right. The images show many areas with water temperatures high enough for no sea ice to be present. The green circle on the right marks an area where the sea surface temperature is minus 1.6 degrees Celsius. Click on images to enlarge. The combination image below shows, on the left, temperatures above 0 degrees Celsius forecast over much of the Arctic Ocean, including the North Pole for June 17, 2026, adapted from Climate Reanalyzer on the left, and on the right, sea ice concentration on June 16, 2026, adapted from NSIDC. Click on images to enlarge. On land in the northern hemisphere where most people live, the average temperature departure from 1901 to 2000 will rise dramatically with strengthening of the 2026 El Nino, as illustrated by the NOAA plot below. Temperatures can be expected to rise dramatically in the course of 2026 for a number of reasons, including acceleration of the temperature rise over the years, more than 1 degree Celsius rise from 2013, as illustrated by the green trend in the above image, and rising strength of the 2026 El Nino. The image below should act as a warning, illustrating the danger that the upcoming El Nino could trigger a rapid and steep rise in temperatures on land in the northern hemisphere in the course of 2026 that could cross the 3 degrees Celsius threshold. From earlier post, the above image shows land-only data in the northern hemisphere through March 2026, with a polynomial trend added that points at 3 degrees Celsius crossed later in 2026. About 0.5 degrees Celsius of the rise can be attributed to El Nino, with further contributions from feedbacks and further forcers. Note that the 1901 to 2000 base is not pre-industrial. The outlook may be even more dire when using a genuinely pre-industrial base. The image below, adapted from tropicaltidbits.com, shows a temperature forecast for January 2027, with high temperature anomalies showing up all over the Arctic Ocean and over areas where currently sea ice is present around Antarctica. This indicates that there will be dramatic loss of Antarctic sea ice. The images below show forecasts for the monthly sea surface temperature anomaly, SSTA, from December 2026 through March 2027, further confirming indications that there will be dramatic Antarctic sea ice loss. SSTA, December 2026, SA, January 2027, SSTA, February 2027, SSTA, March 2027, Antarctica. The image below, from Berkeley Earth Temperature Report for 2027, illustrates the importance of Antarctic sea ice loss in accelerating the temperature rise in 2020 to 2023, compared to 2010 to 2019. Image from earlier post, the red color on the above image shows an area with an extra radiative forcing of 2.1 W/M2, which is primarily the result of loss of Antarctic sea ice. This additional radiative forcing of 2.1 W/M2 is about as much as the change in radiative forcing caused by all carbon dioxide released by people from 1750 to 2019, according to IPCC AR6 figures, image right. Antarctic sea ice area was only 1.09 million km 2 on February 22nd, 2023, very close to the 1 million km 2 threshold when a blue ocean event could be called, as illustrated by the image on the right from an earlier post. Loss of Antarctic sea ice causes albedo loss, which can dramatically increase sea surface temperatures of the Southern Ocean. The image below is created with Southern Hemisphere January 2001 through May 2026 NOAA data, with a trend added to highlight the danger of accelerating sea surface temperature rise and subsequent Antarctic sea ice loss. The danger of accelerating sea surface temperature rise and subsequent Antarctic sea ice loss is further highlighted by the image below. The image, adapted from tropicaltidbits.com, shows a 7-day change in sea surface temperature anomalies that is hitting Antarctic sea ice hard. The image below, adapted from Copernicus, shows Antarctic sea ice thickness on June 10th, 2026. High sea surface anomalies around Antarctica and thinning of Antarctic sea ice are not only due to the strengthening of the 2026 El Nino, but also due to a number of feedbacks that are not only strengthening, but that are also amplifying the impact of each other, including loss of albedo and loss of the latent heat buffer, accelerating global temperature rise, stronger wind as temperatures rise, and rising salt content of the sea surface of the Southern Ocean. The mechanism behind the rise in salinity is discussed below. A recent study led by Robert Massam describes how stronger wind can cause stronger waves that can break up and pulverize ice flows into small fragments and slush, and that can also cause ice flows to flood over, resulting in ponds of seawater that enable algae growth. Unlike melt ponds, seawater wave ponds occur year-round. These feedbacks all reduce albedo, further speeding up the melting of sea ice. Saltier water, less sea ice. From earlier post, until 2015, rising temperatures resulted in melting of ice and enhanced precipitation that freshened the surface of the Southern Ocean, exacerbated by increasing stratification that prevented mixing. The temperature rise over the years also caused winds to be stronger, at the time causing the sea ice to spread out wider. The higher the water's salt content, the lower its melting point. Seawater typically has a salinity of about 3.5%, 35 grams of salt per liter of water. Sea ice starts melting when the temperature rises to about minus 2 degrees Celsius, 28.4 degrees Fahrenheit. By contrast, fresh water remains frozen as long as the temperature remains below 0 degrees Celsius, 32 degrees Fahrenheit. A recent study led by Theo Spira finds that in 2015, anomalously strong winds enhanced mixing across the thin winter water layer, entraining warm and salty subsurface waters, which broke down upper ocean stratification. Another recent study led by Earl Wilson found that in 2015, intensified wind-driven upwelling reversed the freshening trends, releasing years of accumulated ocean heat that contributed to unprecedented sea ice loss. A recent study led by Danian warns that Antarctic regions, 60 degrees minus 90 degrees may warm by around 6 degrees Celsius due to the collapse of the Atlantic Meridional Overturning Circulation, AMOC. A recent study led by Aditya Narayanan finds that East Antarctic sea ice loss was primarily subsurface driven via enhanced upward circumpolar deep water flux, whereas West Antarctic sea ice loss was also forced by long-wave radiative flux anomalies. Findings suggest that persistent upwelling favorable conditions under anthropogenic forcing may push the Southern Ocean into a prolonged low sea ice state. Image from 10 degrees Celsius or 18 degrees Fahrenheit warmer by 2021. An earlier post discusses the finding of a study led by Alessandro Silvano that around 2015, surface salinity in the Southern Ocean began rising sharply, just as sea ice extent started to crash. The post also points at the danger that heat, previously stored in the deep ocean by sinking circumpolar waters, will instead remain at the surface and cause atmospheric temperatures to rise, as illustrated by the image on the right. The post warns that higher temperatures come with feedback such as stronger wind and stronger evaporation, resulting in increased water vapor in the atmosphere. Post further warns that while much of the water vapor will return to the surface in the form of precipitation such as rain and snow, part of this precipitation will fall over Antarctica, with the net result of an increase in salinity of surface of the Southern Ocean, facilitating increased melting of Antarctic sea ice. The image below from a 2025 study led by Wei Wong shows that while Antarctic sea ice has decreased over the past few years, the Antarctic ice sheet has gained mass recently. Driven by extratropical cyclones, strong winds can transport heat and moisture from the warmer Southern Ocean deep into the interior of Antarctica, where the water vapor condenses to fuel heavy snowfall events, as warned about in studies such as a 2025 study led by Jonathan Will and a 2026 study led by Kyohei Yamada, and as illustrated by the combination image below showing a forecast for June 2nd, 2026 for Antarctica of temperature anomalies left and wind speed right. Ominously, the image below shows a relative humidity, RH, of 100% at the location marked by the green circle at 70 hours PA over Antarctica on June 18, 2026. This 70 hours PA is a pressure level corresponding with an altitude in the lower stratosphere. RH shows the capacity of the atmosphere to hold water vapor. Below 0 degrees Celsius and at 100% RH, water vapor starts turning into ice crystals that can fall down as snow. The image below, also adapted from nullschool.net, shows a relative humidity of 100% on June 18, 2026, at the surface at the location marked by the green circle. Conclusion. The situation is dire and unacceptably dangerous, and the precautionary principle necessitates the danger to be acknowledged, while facilitating rapid, comprehensive, and effective action to reduce the damage and to improve the outlook where needed in combination with a climate emergency declaration, as described in posts such as in this 2022 post and this 2025 post, and as discussed in the Climate Plan Group. Links NSIDC National Snow and Ice Data Center. Sea Ice Today, nsidc.org/c-ice-today/c-ice-tools/charctic- interactive-c-ice-graph, Climate Reanalyzer.org, NOAA. Seasonal climate forecast from CFSV, www.cpc.ncep.noaa.gov/product/CFSV2/CFSV2_body.html, tropicaltidbits.com, www.tropicaltidbits.com, NASA, worldview.earthdata.nasa.gov, NOAA, Climate at a Glance time series, www.ncei.noaa.gov/clim-at-series/m/ocean/time-series/1-850-2026, NOAA, ENSO, recent evolution, current status, and predictions, www.cpc.ncep.noaa.gov/products/analysis, _monitoring/land/enso_evolution-status-web.pdf NOAA, El Nino, Southern Oscillation, ENSO, diagnostic discussion issue, June 11th, 2026, www.cpc.ncep.noaa.gov/products/analysis_monitoring/enso_advisory/ensodus.shtml NOAA. Strength probabilities, cpc.ncep.noaa.gov/product/analysis_monitoring/enso/ronnie/dot strengths, the influence of ocean waves on Antarctic sea ice albedo and seasonal melting, and potential coupled physical and biological feedbacks by Robert Massam and others. tc.c copernicus.org/article/20/327/1/2026. Also discussed on Facebook at www.facebook.com/groups/Arctic News/posts/10164358963719679 University of Bremen. Data browser data.seis.uni-bremen.de/data browser. European Union Copernicus Marine Service Data HTS USpace.Europa. EU components Earth Observation Copernicus Image of the Day Sea Ice Cover Bellingshausen Sea Antarctica Nullschool.net Relative Humidity Earth.nullschool.net. Also discussed on Facebook at www.facebook.com/groups/Arctic News/post/10164364227369679 spatiotemporal mass change rate analysis from 2002 to 2023 over the Antarctic ice sheet and 4 glacier basins in Wilkes, Queen, Maryland by Wei Wang et al. 2025. Link.springer.com/article/10.1007/S114300-024-15000- www.eurocalert.org/news-releases/108053 atmospheric rivers in Antarctica by Jonathan Will et al. 2025. www.nature.com/article/S43017-02-4-00638-7 Interannual Variations of Precipitation Events at Dome Fuji Station, Antarctica by Kyohei Yamada et al. 2026. agupubs.onlinelibrary.wiley.com/doi/10.1029/2025JD045296. Also discussed on Facebook at www.facebook.com/groups/Arctic News/posts/10164385286809679 Double Blue Ocean Event 2026 to 2027 arctic-news.blogspot.com/2026/04/double-blue-ocean-event-2027.html Ocean heat threatens sea ice arctic-news.blogspot.com/2026/05/ocean-heat-threatens-sea-ice.html Transforming Society arctic-news.blogspot.com/2022/10/transforming-society.html Climate Plan arctic-news.blogspot.com/p/climateplan.html Climate Emergency Declaration arctic-news.blogspot.com/p/climate-emergency-declaration.html Labels Antarctic Arctic Blue Ocean Event Double El Nino Sea Ice